So previously, we're looking at Newton's law, the first law and the second law. Good morning. Today, we're going a little bit further with Newton's laws. And let's find out what more we can learn. Before we start off with today's work, let us also remind each other about our textbook, Revolutionary Science Workbook Study Guide 1, which you can get the information that we'll be teaching you on, further explanation on some of the things that you need to know for this particular subject. But in order to remove some cobwebs from our heads, let's start off with a simple question this day and find out if you still remember some of the concepts that you have learned. Here is a question that says, which one of the following equations for the magnitude of the normal force N is correct? Let's look at the diagram. What does the diagram show us? It shows us weights on a force diagram and normal force, which we know the definition of. We have got a force of F at an angle of theta, right? And the question is, what is the magnitude of the normal force? Is it A? Normal force is equal to W plus F cos theta. Where are we getting the F cos theta from? Do you remember resolution of forces? Yes, there is a horizontal component of that force, and that horizontal component is along the horizontal and is given by F, who remembers? Cos of theta, you're right. And the vertical component is given by F sine of theta. So what is happening is this object is slightly being moved upwards by a force F sine theta. So the weight is sort of being lifted off the surface a little by a component F sine theta. So now think about it. How much is the surface onto which the object is on, normal force, going to exert upwards? Think about it quickly. Did you say the answer is D? Well done, you got it right. We are removing the cobwebs from our heads. Today's lesson is mainly on Newton's third law of motion. Newton's third law of motion says when a body exerts a force on a second body, the second body exerts a force of equal magnitude but opposite in direction to the first body. Look at the example of the picture on the board. We got a nice teacher's apple and the textbook that has got a black cover. The apple is exerting a force on the textbook, and the textbook exerts also a force on the apple. The magnitude of that force is equal but opposite. We can also talk about the book with the black cover and the book with the blue cover. We can talk about the desk and the book that's just on the desk right there. So that, in essence, is Newton's third law. Very easy. We must be able to state Newton's third law. Newton's third law is also known as the action-reaction forces. Forces always occur in pairs. One action and the other is a reaction, right? Which together constitutes the interaction between one action and another. Note that action and reaction forces are always occurring at the same time, simultaneously, and act on different objects. Neither force exists without the other. we can think about the properties of action-reaction forces in this regard. Let's look at our uncle who's sitting on his lovely City Golf. Can you identify action-reaction forces here? Yes. Uncle applies a force on his City Golf. The City Golf applies an equal but opposite force to uncle. The City Golf is applying a force onto the ground. The ground is applying an equal but opposite force to the car. All right, so that in itself is identifying action and reaction forces. Here is a practice question that we can think about and look at quickly. A bullet is shot from a gun. According to Newton's third law, the gun exerts a force on the bullet, and therefore the bullet exerts a force on the gun. What can you say about the directions of the two forces described above? What can you say according to Newton's third law? Think about it. They are opposites in direction. Right? What can you say about the size of the two forces? Another word for size you must know is magnitude. They are equal in magnitude. Is the backward velocity, the recoil of the gun, the same as the velocity of the bullet? So the bullet has been shot. Is the velocity of the gun going to be equal to the velocity of the bullet? It's something that we can scratch our heads about. Absolutely not. Something is faster than the other. What is faster? The bullet is faster. It's got a greater velocity than the gun. The question says, explain your answer. Because the gun is heavier and the gun is being held by the hands. And the muscles, you can see the tout muscles on the man's hands there, they prevent the gun from going back. So in that way, the backward velocity of the gun is less than that of the bullet. That makes us understand Newton's third law. Now that we have done Newton's first law, Newton's second law, Newton's third law, we can be able to answer questions, especially question 2 in our exam papers, that require an amalgamation, mixing up together of the 3 laws. Here is November 2015 exam paper that is saying 2 blocks of mass m kg and 2.5 kg respectively are connected once again by a light inextensible string. The string runs over a light frictionless plate. As shown in the diagram below, the blocks are stationary. Stationary. What does stationary tell us? The blocks are not moving. What does question 2.1 ask us to do? It asks us to state Newton's third law in words. Do you remember Newton's third law? You must be able to state Newton's third law. Think about it. When a body exerts a force on another body, right? The second body exerts an equal force in magnitude, but opposite in direction. You must be able to state that. If you can't remember, rewind and write it down. And you must know what Newton's third law says because the examiner requires us to. Next question says, calculate the tension in the string. This one we need to work out a little. That's question 2.2. Sorry, question 2.12. It says calculate the tension within the string. So what is happening? I'll draw myself a small free body diagram that's showing the 2.5 kg block, right? Let me give it mg, mass times gravity, and an upward force that is showing the tension. What do I know about this tension? This tension is equal to mg. What makes me think that the tensional force is equal to mg? What makes me think that these two forces are equal? I underlined the word stationary. The system is not moving. So my tension is going to be equal to mass 2.5 multiplied by 9.8. Tension is calculated in newtons. Pull out your calculator. Here is my blue baby. And calculate 2.5 multiplied by 9.8. And there you got an answer of 24.5 newtons. Let's write it down. 24.5 newtons. Done and dusted. Let's move on to 2.13. 2.13 then says, the coefficient of static friction, mu s, we have met before coefficient of kinetic friction, right? This now is the coefficient of static friction. Why static? Because the system is stationary between the unknown mass m and the surface of the table is 0.2. The question says calculate the minimum value of m that will prevent the block from moving. Why do we talk about minimum value? Because if the value is higher than the minimum value, there won't be any movement. It will be stationary. If we add another mass, it's going to be still what? Stationary. So what are we looking for? We are looking for the minimum value. Okay? So let's find that minimum value. How do you think we will come up with the minimum value here? The minimum value is going to come from using Newton's second law. Think about it. The objects are stationary. We hear that mu s is equal to 0.2, and this mu s does not have units because it is a ratio. So we want to find the minimum value of m. We have got our free body diagram there, right? Let's look at for the 2.5 kg block. How can we represent that 2.5 block according to the tension? We see that the tension is equal to 24.5 newtons. And if that tension is 24.5 newtons, right? And the mu s is 0.2, it means that the tension also for the mkg block, tension will be equal to 24.5 newtons. So if the tension is 24.5 newtons, and the only thing, if I am to draw a free body diagram for M, that is stopping it from moving is the Fs, then we can safely say that tension, right, is equal to Fs. So our tension of 24.5 is equal to, how do we calculate Fs? At the back of every question paper, you have a list of formulas. One of the formulas you would find there is mu s multiplied by the normal force. But also we understand that the normal force is given by m times g. And in this case, we are talking about the value of the big M. So we can substitute n, 24.5 is equal to mu s multiplied by that big M that we are trying to calculate times g. Okay, so let's substitute 0.2, 24.5 times big M multiplied by 9.8. We can calculate the value of M, 24.5 divided by 0.2 times 9.8. I hope you see what I've done there mathematically. Just for us not to waste time, pull out your calculator, calculate 24.5 divided by 9.8, right, times 0.2, and your answer should be equal to 12.5. Mass is in kilograms. Voila! We are done with that question. 2.13. Let's move on to 2.15. 2.15 then says the block of unknown mass M is now replaced. So the block of unknown mass M is now replaced with a 5 kg. If the block of unknown mass M was 12.5 kgs, and now we replace it with a 5 kg, a small one, what do you expect to happen? There will be an acceleration, right? In which direction? Downwards. And remember, it's a system, so the acceleration in this case is going to be equal acceleration. So we have replaced the block of of mass M with a block of 5 kgs, right? The 2.5 kg block now accelerates downwards. We figured that one out already. The coefficient of kinetic friction, now kinetic friction comes into play, is 0.15. Now look, coefficient of kinetic friction is different from coefficient of static friction. How do they differ? Coefficient of kinetic friction is less than coefficient of static friction. Think of it this way. It's easier to move something that's already in motion than to start something moving that is stationary. So that gives us an idea as to why coefficient of static friction is more than the coefficient of kinetic friction. What does the question say? The question now asks us to calculate acceleration of the 5 kg block. Have I met anything like this before? Of course I have. Where have I met it? When I was looking at Newton's second law. Now, let's look at the calculation for this question. Here we are done. We found our 12,5 for this one. Let's put down 2,14 and do the calculation. 2,14. What am I looking at? For the 5 kg block, what is happening? The object is going to accelerate. So this has been replaced by a 5 kg block. And our acceleration is in that direction, right? So which means the tension is going to be greater than the friction, all right? So we would say then tension minus, or vector sum, plus frictional kinetic is going to be equal to mass times acceleration. We don't know the value of the tension at this point, but what we can calculate is kinetic friction, 0,5 times the normal force, which is times 5 times 9,8 is equal to mass. New mass is 5 times acceleration. Take out your calculator. Let's form the first equation here. So our first equation is going to be 0,15 multiplied by, do this with me, 9,8, don't lag behind, all right, is equal to 7,35, right, plus minus 7,35 is equal to 5a. All right, this is our simple first equation. All right, let's look at the next one, which is for the 2,5 kg block. What is the equation? We got tension upwards and it's accelerating downwards, which means at this instance, the mg is going to be greater than the tension. So it's going to be mg plus vector sum minus tension is equal to mass 2,5 times acceleration. From the equation, we know the mass is 2,5 multiplied by 9,8 minus the tension, which we don't know, is equal to 2,5a. We can form the second equation, which is 2,5, pull out your calculator, multiplied by 9,8 is equal to 24,5 minus t is equal to 2,5a. Now we've got two equations that we can solve simultaneously. What we are looking for is the acceleration. So how am I going to do this? The t's will cancel. These will add together. So 24,5 minus 7,35. Okay? It's going to be equal to 17,15. Let's just put that step down. Is equal to 5 plus 2,5. Depending on how your teacher taught you to do simultaneous equations, some you would make t the subject of the formula and then equate the two equations. However you do it, but I would do it this way, 7,5a divided by 7,5 divided by 7,5. Acceleration, therefore, is going to be equal to 17,5 divided by 7,5. My final answer is 2,29. It's actually 2,2866, but I just put it as 2,29 to 2 decimal places, meters per second squared. Is my final answer for 5 marks. I am done with that question. Okay, that should be easy. Piece of cake, right? So what have you seen here? We have been asked about Newton's third law. We have been asked about Newton's second law. We have applied our understanding of the 2 laws in order to come up with the final answer for that question. Listen, here is one from from the November 2019 exam paper. It says that a block is pulled at a constant force of 40 newtons at an angle of 25 degrees to the incline. Might look different, might look weird, but don't be afraid. The same concepts, the same rules are applicable in a question. So you got P, you got Q, relates to the diagram to what is given. Block P moves at a rough section AB on the incline, while block Q moves on a frictionless section BC of the incline. See the diagram below. An average constant frictional force of 2,5 newtons acts on block P as it moves from A to B. Now after B, we know that there is no friction here. This is a frictionless surface. That we keep in mind, because that's what the story is telling us. Excellent. All right, so what does the question say? Let's pick up the question and find out what this question says. This one we are done and dusted. Let's remove it. You can rewind and go back to it if you need to. But as for now, we are moving on to the next one. This is November 2019. 2.1. Come on, examiner. Would you think we won't know the answer to this question? State Newton's second law in words. By now, you must be able to clearly state Newton's second law in words. If not, here is the advice. Write it down. Stick it up on your ceiling. That is, you lie sleepless at night, you may remind yourself of Newton's second law. Or stick it behind the toilet door. That each time you visit the toilet, maybe you can read it and remember it. Okay, now draw a labeled free body diagram for block P. So, what is happening to block P? So 2.1, I am sure we must get those marks. If not, go back to the video on Newton's second law and remind yourself what it is all about. 2.2, a free body diagram. A dot represents the object and the downward force, in this case, is representing the frictional force, Fk. We also have F, G parallel, right? And we've got a tension, normal force. Okay. I don't want to put in the FG parallel in this instance because I can't mix it up with the weight, components and the weight. I'll just leave it as simple as this, remembering that in my calculations later, I might have to resolve the forces. So let's look at it quickly. There is friction, yes there is. There is tension in the rope. There is normal force acting perpendicular to the surface. There is the weight, which is equivalent to mass times gravity. That's at the back of my mind as I'm busy working through this question. Next question says, calculate the magnitude of the acceleration of block P while P is moving on section A and B. It's a system. So the acceleration of block P is equal to acceleration of block Q. Let's look at 2.3. 2.3. So for block P, what do we have? We know it's accelerating upwards, so tension should be more. Plus, minus friction force coming down, right? Plus, minus the components of the weight, which is F, G, parallel, is going to be equal to mass times acceleration. I'm forming the equation for block P, right? So, this is the F net. In other words, we are saying F net is equal to mass times acceleration. I've just substituted here quickly. So tension minus frictional force, we know it's 2,5 minus Fg parallel. How am I going to find Fg parallel? You know the resolution of forces, right? Fg parallel is the weight 2 times 9,8 multiplied by the angle, the sine of the angle, 30 degrees, is equal to mass of 2,5 times acceleration. You can pull out your calculator quickly with me. Let's do it. So it's minus 2,5 minus 2 times 9,8 times sine of 30 degrees is equal to, I'm getting T minus 12,3. Always check your work, cross-check to see if your calculation is right, you've put in the right answer. Your calculator has got a reverse where you can always go back to see if you've calculated the correct thing. Reverse it, 2,5 negative, all right, minus 2 times 9,8 multiplied by sine of 30. So 12,5 is equal to 2,5a. So that's my equation 1. Now let's look at Q. Something interesting is happening to Q. Remember, with Q, there was not a horizontal force, but there is a force at an angle. So if you look at Q, right, it's on an incline, but then it's got a force lifting it up, and that force is equivalent to 40 newtons, right? And it's at an angle of 25 degrees, which means that the normal force, or which means that, excuse me, the force is slightly being lifting the 3 kg block upwards by a component of Fg, a component of 40 sine of 25. So the weight of this object is going to be less by 40 sine 25 because it's slightly being lifted up off the surface. Now, if you've got that in mind, then you understand that the weight of this object is equal to 3 times 9,8 minus 40 sine 25. That is the tricky part on this question. Once you have figured out that, the rest should be quite easy. So find the weight of that object for me. 3 times 9,8 minus 40 sine of 25. And that should give us an answer of 12,49 ... Don't put it into 2 decimal places yet, because we need to use the answer to the degree of accuracy at the last part. So for block Q, what do we have? We have got F net also equal to mass times acceleration. What will be the F net? It will be F x minus, there is no friction, so we are subtracting Fx minus the tension is equal to mass times acceleration. Very easy. So what is Fx? Right? Fx is 40 minus also, I left out, minus the Fg parallel, okay, is equal to mass times acceleration. So it's 40, this force that's working this way is 40 cos of 25 minus the tension, okay, minus Fg parallel, of which Fg is mass times gravity. We already have the weight, okay, 12,49 ... and it's working downwards. Sine of 30 degrees is equal to a mass of, we agreed that the mass is going to be 3 times acceleration. Okay, so you pull out your calculator, you already have this answer in your calculator. So you make it minus, you are adding it to, so let's say minus answer, you are adding it to 40, the cos of 25 degrees, right? And that's going to give you 23,75 ... because we are using it later. It's a positive value. Minus tension is equal to 3a. Here is our second equation, right? Now I've got my first equation here and my second equation. Work them out simultaneously like what we did before. So these two are adding up together. My recall answer plus minus 12,3 is going to be equal to, and then divided by 5,5 from these two. Let's see, divided by 5,5 from those two. My final answer will be acceleration is equal to 2,08 ... meters per second squared. But the question is asking me to find acceleration, so I can approximate to 2 decimal places, and that's my final answer. Quickly, if the block P is now past the point B, what will happen to the acceleration? No more opposition from friction. So what will happen to block P? Is it going to have a greater acceleration, a smaller acceleration, or an acceleration equal to? The acceleration is definitely going to be greater. Why? Because there is no more friction. Think about it, look at it, and enjoy. Ciao from Chiefs.